Oceanic garbage patches by Group 2. Here is an introduction to oceanic garbage patches. Oceanic garbage patches are the result of oceanic and atmospheric currents that combine to form a gyre. These gyres capture the plastic and garbage from all around the world. There are 5 main gyres: the North and South Atlantic gyres, the North and South Pacific gyres, and the Indian Ocean gyre. The Big Five help drive the oceanic conveyor belt that helps circulate ocean waters around the globe. The Mediterranean Sea has also been a victim to these garbage patches. Currently, the biggest oceanic patch is the Great Pacific Garbage Patch, also called the Pacific Trash Vortex. This is an enormous area of polluted marine habitat in the North Pacific Ocean. The vortex spans from the coast of North America to the coast of Japan. The patch is the result of 4 oceanic and atmospheric currents that combine to form the North Pacific Gyre, also known as a North Pacific Subtropical Gyre. The gyre collects garbage from the coast of North America and Asia from marine vehicles passing through the Pacific. Who discovered the Great Pacific Garbage Patch? The Great Pacific Garbage Patch was the first oceanic garbage patch ever discovered. In 1997, Captain Charles Moore identified this discovery after he had competed in the Trans-Pacific Yacht Race in which he had sailed from California to Hawaii. Moore noticed collections of plastic debris floating on the surface of the water. He kept a log of the discovery, documenting the number of times he noticed floating deposits of plastic and other waste. Moore's discovery, with predictions about the effects of oceanic currents on marine debris, was published in papers from the National Oceanic and Atmospheric Administration, or the NOAA, in the late 1980s and the early 1990s. Moore alerted oceanographer Curtis Ebbesmeyer, who began working with Moore on a systematic study of pollution in the Pacific. In 1999, Moore and Ebbesmeyer published one of the first studies of the phenomenon. That same year, Moore's Algalita Marine Research and Education Organization refocused its mission on researching marine waste and preventing marine pollution. Included in this presentation is a video regarding the Ocean Cleanup Project. You can also find out more information by selecting the link below or help fund the Ocean Cleanup Project. So, you might be asking, where are these gyres and the garbage patches around the world? Garbage patches are found in the calm, stable centers of many of the world's ocean gyres. Even smaller bodies of water, such as the Mediterranean and North Seas, are developing their own garbage patches along heavily trafficked shipping lanes. This information was found by National Geographic. According to a 2015 report, much of the world's output of plastic waste originates from China. The nation accounted for approximately 27.7% of the world's total plastic waste production, and millions of metric tons ended up as marine debris. Let's first take a look at the North Atlantic Ocean. The newly described garbage patch sits hundreds of miles off the North American coast. Although its east-west span is unknown, the patch covers a region between 22 and 38 degrees north latitude, roughly the distance from Cuba to Virginia. Let's also look at the South Atlantic Ocean. South Atlantic's garbage patch, predicted by surface drift models, where most litter was made up of plastic, this is roughly 97%. Let's look at the South Pacific Ocean. In January 2013, researchers announced that the South Pacific is home to a newly discovered garbage patch. The South Pacific Gyre is a set of circular currents containing a high concentration of plastic pollution. Let's focus on the Indian Ocean. Discovered in 2010, the Indian Ocean garbage patch was found circulating within the Indian Ocean Gyre. Let's look at the Mediterranean Sea. More recently noted, nearly 250 billion pieces of plastic, which equal to approximately 500 tons of trash, is floating in the Mediterranean Sea. Most of the plastic particles identified were microscopic, with each piece roughly weighing about 1.8 milligrams or less. Let's take a look at the North Pacific Ocean. Discovered in 1997, the Great Pacific Garbage Patch is the largest of the 5 garbage patches. Shifting winds and currents make its size impossible to measure. Debris from the North American coastal waters ends up in this garbage patch. So, what are the facts? Currently, there are approximately 7 million tons of weight floating in the Pacific Garbage Patch. This is twice the size of Texas and can range up to a depth of 9 feet. In the Great Pacific Ocean Gyre, there is 6 times more plastic than plankton, which is the main food source for many ocean and marine animals. By estimation, 80% of the plastic has originated from land, floating in rivers to oceans or carried by the wind, ultimately finding its way to the ocean. The remaining 20% of plastic originates from oil platforms and ships. According to scientists, it is the largest plastic dump on Earth. This means plastic patches are larger than waste dumps on land. These trash patches consist of 80% plastic. Scientific research from the Scripps Institution of Oceanography in California, U.S., shows that between 5 to 10% of the fish contain small pieces of plastic. So what are the effects that garbage patches have on our ecosystem? Although it might seem indestructible, plastic material can degrade into smaller particles due to weathering of the sun and water. These small particles are called microplastics and can soak up heavy metals and become a strong pollutant for marine ecosystems. Aquatic life and birds can mistake microplastics for food. If they survive and are later eaten by other fish, these toxins will be introduced into the food chain and can ultimately result in human consumption. It is estimated that around 1 million marine birds and 100,000 marine mammals die due to ingesting plastic every year. Marine life can also become entangled by the debris, causing serious physical harm and resulting in ghost fishing, which is when lost or abandoned fishing equipment continues to catch fish that go to waste. Additionally, this floating plastic waste is constantly transporting microbes and microorganisms to areas where they do not exist before. This negatively impacts the ecosystem as it introduces invasive species to areas where they compete with native species for resources. Animals are not the only ones affected by these garbage patches. Marine debris has a serious negative impact concerning human health. Microplastics can make their way into humans by the consumption of seafood or drinking of tap water. Other debris, such as glass or medical needles, has been known to wash up on beaches, posing an immediate threat to humans. This is not only hazardous but also unethical. Excess debris has also impacted the economy. Concerning tourism, tourists have ceased visiting beaches where there is an abundance of trash due to distasteful presence. Real estate has also been affected, as housing values have decreased in areas where trash floats near waterfront homes, leaving an unpleasant appearance and smell. How do these garbage patches occur? A gyre is an accumulation of multiple different ocean currents, including both surface and deep water, termed the global conveyor belt. The global conveyor belt is important for regulating the oceans by circulation of water through properties such as temperature and salinity. Surface ocean currents are low in nutrients and move predominantly by wind from the rotation of the Earth and the Coriolis effect. The Coriolis effect controls the rotation of water in different hemispheres, such as moving anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. As the surface ocean currents move toward the poles, it is then chilled by the temperature of the air. This leads to formation of ice. Salt does not freeze when ice starts to form, which causes the level of salinity in the water to rise, subsequently increasing the density. Water with greater density sinks to the bottom in a process known as downwelling. When the dense water sinks, it is then replaced by the water from the surface current, creating a deep ocean current. The deep ocean current will travel along the seafloor throughout the ocean. The seafloor is high in nutrients from the lack of sunlight and low productivity. When the deep ocean currents travel to the equator, the currents begin to heat up and become less dense, soon rising to the surface. The process of water rising is called upwelling. Upwelling currents are high in nutrients and enrich the surface waters, leading to high productivity. In turn, this makes the global conveyor belt vital to the ocean's food chain and supporting the growth of primary producers. The ocean currents are moving in a predicted circular pattern along the continents, otherwise known as gyres. The center of these gyres are very calm and stable. With that being said, these areas have low nutrients, thereby supporting little biodiversity. While the ocean currents move past these continents, they are collecting trash that has accumulated in the ocean. The trash then flows with currents and will end up stuck in the place in the center of the gyre. Most of the trash that ends up here is not biodegradable, but it will eventually be degraded into smaller pieces of plastic, which are harmful to wildlife. Let's discuss tracking of these garbage patches, including equipment, techniques, and government involvement. Some of the equipment used to track and monitor these patches, such as from the NOAA, where they have used drifters for decades. These are buoy-like devices used to collect specific data about ocean conditions, which assist in the prediction of the movement of garbage patches, as well as determination of the size of the patches. Today, there are over 15,000 drifters floating in our world's oceans. This has been previously reported by the Miami Herald. Other equipment used to track and monitor these patches. Perhaps the most famous technology used to track and clean the oceans is one pioneered by a company called the Ocean Cleanup. Their system, aptly named System 001, is a massive semicircular flotation device that suspends a screen underneath the water to catch debris. It has been designed in such a way that the system moves at very low speeds, allowing sea life to swim out of its path. It also forces ocean currents underneath the screen, which helps prevent immobile sea life from becoming trapped. This device is also 100% energy independent, relying only on the natural currents of the ocean to move it about. Through rigorous testing and analysis, the company has estimated that a full deployment consisting of approximately 60 systems could reduce the Great Pacific Garbage Patch by 50% in just 5 years. This was reported by the Ocean Cleanup. Governments at the forefront of tracking and studying. A select group of the world's governments have placed greater importance on this ever-growing issue of oceanic pollution and have thus allocated more funding towards the tracking and studying of these garbage patches. The prime movers in the industry are the European Union and the United States. The European Union funds a project called Topios, which produces modeling framework to help better understand the sources of the garbage, such as how much is present and where it will travel to next. The EU includes countries such as Spain, France, Germany, Italy, Belgium, and Austria. Let's look at the U.S. A vast majority of most influential environmental protection companies are based in the United States. These include the Natural Resources Defense Council, the Environmental Defense Fund, and the more innovative and artistic side, Parley for the Oceans. There are several different methods currently being applied and tested with the overall goal to slow the oceanic disposal of human waste. For example, Dutch student Boyan Slot raised $30 million in order to fund his project to clean the ocean. His idea uses a large pipe that collects different plastics and debris scattered on the ocean surface, which is moved by the waves of the ocean so that it never is stationary. Although it sounds simple, this method requires the presence of a large structure used to hold the waste temporarily in order to be picked up for eventual relocation. There has been a link included in this presentation for you to find out more information. Here's some more information about the cleanup efforts of the Great Pacific Garbage Patch. A study in 2010 indicated that China, the primary contributor of world waste in most areas, reached almost 5 billion pounds in waste. Cleaning does not come cheap. As previously mentioned, the Dutch engineer raised $30 million, which is only a drop in the bucket compared to what is needed to actually clean up the current patch and keep it empty at a consistent rate. A group of scientists estimated the current value of all marine ecosystem services at $16.5 trillion. Those same scientists estimated the cost of cleaning up beaches of the UK at around $18 million. A large part of the cost of the marine ecosystem services and the beach cleanup are derived from labor costs. So how can you help? For example, a local fraternity at FIU promotes occasional beach cleanup events at various locations in South Florida through local organizations. Making a conscious effort at home could also be done, such as reducing waste and reducing energy consumption in order to minimize the amount of waste being deposited into the Pacific Patch. Yachting, boating responsibly is also important in the regard that you manage your trash, abide by the rules of the Coast Guard, and clean up any garbage that you come across. Education and lifestyle modifications can be made in the favor of our marine ecosystem sanitation. So let's talk about the plastic problem. Worldwide, the production of plastic has increased exponentially over the last half century. The effects of this plastic problem is not just isolated to our ocean waters. Research has clearly indicated that entire ecosystems suffer from the harmful effects of plastic pollution. Even the sun, which is the first step in the food chain, inadvertently plays a role in this plastic predicament. Through the process of photodegradation, plastic debris is transformed into tiny microparticles occupying these patches. So who are we in the face of plastic pollution, and what is the solution? The solution to plastic pollution. The ocean plastic problem enacted by Parley for the Oceans, in which the centralized idea was developed and that one person alone cannot combat this perpetuating issue. Prolonging and turning a blind eye to a resolution will also ultimately lead to a detrimental outcome. Some of the methods to prevent this disaster from worsening include collaboration, direct action, research, and development. Let's talk about collaboration. We must strive for communication, education, and raising awareness concerning issues regarding ocean pollution. Let's make a conscious effort. For example, not all plastics are recyclable. Direct action. Reducing consumption and reusing of materials in efforts to prevent excess waste. Retrieving and recycling, ensuring appropriate methods are taken for proper disposal. Advocate and push for your legislators and lawmakers to create and enforce new laws to uphold better industry standards. Become involved. There are multiple levels of involvement, ranging from an individual level or a personal level to local, regional, and government levels. Research and development, we must persist to continuously research for new methods and actions to take. At this point, we must consider prevention, such as the decreased use of plastics. Overall, human impact in the plastic industry has primarily influenced the problem with plastic pollution. Despite being the perpetrators, we alone are the solution. Through prevention, reevaluation of our perceptions, and realigning our priorities of plastic consumption, we can make improvements to this detrimental predicament that globally affects our ocean waters. Ultimately, we must choose plastic or planet.